Okay, number 14, vasodilation of peripheral arteries of the leg will do what? Okay, so will they increase total peripheral resistance? Let's see here. No, they won't. They will actually lower it. Increase the reflected pressure wave? No. Vasodilation, it decreases the pressure waves and it decreases the flow waves. Let's see, increase the reflected wave, so no. Let's see, and it would be D, decrease the reflected flow wave. Okay. Let's see, number 15, a stenosis in the iliac artery that reduces the artery's diameter by 90%. Okay, so if you remember, so we got a stenosis here in the iliac artery. Here's our stenosis. So blood's going this way. Okay, will increase the peak pressure distal to the stenosis? No. Beyond the stenosis, pressure goes down. So we can knock that one out. Cause peripheral arterioles to constrict. Let's see. No, that's definitely wrong because we're talking about arterioles. They will actually dilate to try and auto-regulate. So they will actually dilate. So we can knock that one out. Decrease the amount of flow reversal in the posterior tibial artery. I think that one's true. But let me look at D. D, increase the pressure in capillaries in the foot. No, D is wrong, so it's definitely C. So that goes back to, so this would be the flow reversal. That'd be the flow wave. So the flow wave won't be as intense if you have a stenosis, especially 90% stenosis. So, okay, number 16. Which of the following would increase pulse wave velocities in arteries? Okay, so without even looking at the answer choices, what would increase a pulse wave velocity? Okay, so this is all about compliance, I'm certain. So if we made that artery harder, so here's the artery. If we make it harder, then the wave velocity, so the pulse wave velocity will be faster. So let's take a look at this. So, okay, so increase in blood viscosity. No, actually, increasing blood viscosity would decrease the pulse wave velocity. Increased compliance. No, that would actually. Let's see. No, increasing compliance, that would actually slow it down. Let's see. Increase wall elastic modulus. That is actually the correct answer. But let me look at D first. Increase density of blood. Let's see. Okay, so if we increase the density of blood, that's the exact same thing as that. So that's going to be wrong, which means E is wrong. Okay, so C, increase wall elastic modulus. Okay, so if you remember the elastic modulus, it's stress over strain. And this is one of those physics things where you want to see how much something, how much something deforms when you apply stress to it. So if you increase this, then what it means is that you need to increase your stress to get the same amount of strain, which would be the same thing as saying that the compliance has decreased. It's become, this has become harder. So that is a tough question, but the answer is C. Okay, resistance vessels, number 17, resistance vessels have more blank than similar sized capacitance vessels. Okay, let's look at this. Okay, it's smooth muscle. So resistance vessels are arterioles. And that's what they do, is they have smooth muscle, and the arterioles, if you remember how blood it loses its pressure as it goes through the system. That's not a very good line, but the steepest part of this, where let's say that this is the aorta and blood is losing pressure throughout the body system. This would be the central vein over here. The arterioles control how much it's going to lose. So, and that's because of smooth muscle. So, okay. Number 18, an individual with constant cardiac output and total peripheral resistance, an increase in arterial compliance results in, okay, so increased arterial compliance. Let's think about that. That's going to decrease blood pressure. It's going to slow wave reflections, stuff like that. So let's look at our answer choices. Let's see, so it's going to result in a decrease in pulse pressure. Okay, I think that might be the answer. An increase in mean arterial. Okay, so it's not going to increase blood pressure. Okay, it's not going to increase work. Okay, so yes, A is the answer. A decrease in pulse pressure. So yeah, the pulse pressure, it's the systolic minus the diastolic. So, I mean, this isn't a great answer, but yes, the systolic would have to go down more than the diastolic, and it will, and that's because compliance, it affects the systolic before the diastolic. So the systolic will go down more than the diastolic, and the diastolic doesn't even have to go down.